Today I want to show you my amazing ammonia fountain. Check this out. For this experiment, we'll use 30% ammonium hydroxide, a 2,000 milliliter round bottom flask, a 2,000 milliliter beaker filled with water, blue food coloring, and a handheld torch. This is a 25 milliliter pipette that's inserted inside the round bottom flask. Begin by adding food coloring to your beaker filled with water. This way you'll be able to clearly see the fountain as the water rises inside the round bottom flask. Then add 20 milliliters of ammonium hydroxide to your round bottom flask. Then insert your 25 milliliter glass pipette into your round bottom flask. Now you're ready to start heating the ammonium hydroxide until it boils. This is going to build up pure ammonia gas in your flask, and then you're going to invert it over your beaker filled with food coloring. So I'm going to start heating up the ammonium hydroxide, and pretty soon you'll see it come to a boil. You can start seeing it boiling. And we want to build up as much ammonia gas in the flask as we can. Almost there. You should see some condensation on the top of your round bottom flask as you build up vapor pressure inside the flask. All right, now I'm going to tip it upside down into my beaker of water, and let's watch what happens. I can see water rising. Look at that. Look at that. I have an ammonia fountain. Isn't that amazing? Look at that. What's causing it to rise in the round bottom flask? It's as though it's defying gravity. Look at that amazing fountain. It just keeps going. Wow, what an amazing demonstration. You know, this is all about hydrogen bonding between the ammonia and the water. They're both polar molecules and they're attracted to each other. So much so, it seems to defy gravity itself as that water rises in the flask. Just amazing. Look at that, it's almost full. Just an awesome demonstration. So exciting to watch. It's still going. I'm almost out of water in my beaker. And there we go. And it stays in the round bottom flask even after I lift it out of the beaker. How is that possible? What's going on in this chemical reaction? So what's really going on here? Why does the water rise in the round bottom flask? And when you run out of water in the beaker, why does it stay in the flask even after it's upside down as though it's defying gravity? What's going on here is that ammonia gas is highly soluble in water because ammonia and water are polar molecules. They're attracted to each other. So as the gas molecules dissolve in the water, that decreases the air pressure inside the round bottom flask. So much so that the atmospheric pressure, the 14.7 pounds per square inch of atmospheric pressure, is greater than the air pressure in the flask, pushing the water up into the flask as it's attracted to those ammonia molecules. Just an amazing example of chemistry in action. I love this demonstration. I hope you did too. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.